what I'm going to be doing today is talking a little bit about OCUnit, which is the unit testing framework for iPhone, and the UIAutomation framework, which is a way that you can poke at the application UI. OCUnit is actually relatively well documented, but UIAutomation is, by Apple at least, not documented at all, really. So hopefully I can give you some good pointers here today. So the agenda we're going to go through: I'm going to have a brief introduction. We're going to look at OCUnit, creating test targets and test cases, and then how to use code coverage tools with OCUnit. Then I'm going to move on to the UIAutomation framework, show you how to create a test suite using that, and if we have some time left at the end, then I will go into some other interesting things you can do, but I suspect, given the delay especially, this will eat up all our time. So to begin with, who am I? As Catherine mentioned, my name is James Turner. I've got about 30 years experience as a software developer. Currently I'm working as a senior software engineer at Kronos, who is a workforce management and timekeeping company. We're about an $800 million company, I believe, right now. Also, I am a freelance writer. I am a contributing editor for O'Reilly. You may have seen some of my pieces up on Radar recently. And I am also the author of 2 books on Java, which are now getting out of date. So my experience with iOS testing, I started being an iPhone developer about 2 years ago when I started to develop a simple application to I co-write a comic strip with someone else, and I wanted a viewer for it. So I wrote a simple viewer app. I got it into the store. It was accepted on the first try. And that was pretty much it until Kronos decided they wanted to get into mobile applications, and I was one of the few people at the company with good iPhone experience, so I ended up being the lead iPhone developer on our mobile application, which is going to be coming out shortly for the 3 major smartphones plus J2ME. So when we moved to from the world of writing my own app in XCode to working in an enterprise application, things changed a lot, and I will talk about that on the next slide. The only other thing I wanted to mention here is everything I'm going to show you today comes out of the box with XCode, except for the coverage tool I'm going to use called Cover Story, which is available from the URL you see there, or just Google for Cover Story. It's free. I don't know, it's either GPL or one of the other licenses, and available, I believe, for Mac and PC. I believe it might be a Java tool, but I'm not sure. So what is unique about iOS when you get into enterprise or really more of a production environment? XCode is really good for just developing stuff. It's a very rich environment. It's a great IDE. It's, frankly, in my opinion, at least as good as Eclipse is for Java. But it really is designed for a developer sitting at a desktop working on code solo. There is some source control stuff built into it, but when you get into the things that, in a large company especially, are important, it starts to get difficult. One of the things I found at Kronos is they're used to full regression testing, nightly builds. When we started to get into the question of how is the app going to get in the App Store, saying, well, I've got Xcode on my desktop, and I'm just going to build it there and upload it there. And it's like, no, you're not. You're going to use a fully regressed thing that came off an automated build, because we don't know if what you've got on your desktop is really what's checked in. So then you really get into a much more complicated development environment where some of the tools I'm going to show you today become really necessary, because they're going to say, do you have 80% unit testing on your line coverage? And if you're not doing this kind of stuff, you really don't have an answer to that. Unfortunately, most of the stuff, OCUnit, as I said, is relatively well documented. UIAutomation tool is not well documented, and automated build support is kind of apocryphal and anecdotal. And you get a lot of, well, it's not documented, but if you set these flags on the command line, then you can get the right thing to happen. If you really want to have an adventure, try to build an ad hoc signed build from the command line. It's possible to do, and in fact we're doing it now with an Ant script, but it took a lot of investigation and finding out exactly what directory your key signing had to be done in and things like that. I'm sure Apple has great regression testing for their operating systems and their code, but when it comes to the developer community, the idea of regression testing seems to be a relatively new concept. UIAutomation framework didn't show up until recently. OCUnit's been around for a while, but you don't see a lot of people discussing it in the industry. I think, again, because Mac developers have tended to be more one-man bands traditionally, and certainly, that model has largely held for the App Store. The other complication you run into is that the UI automation I'm going to show you today cannot be fully automated because it requires bringing up the simulator, and it will not automatically terminate when it's done. So there are still limitations to really what you can automate in the enterprise, but you can get a fair amount done actually if you try. So OCUnit is a standard unit testing suite. It's just like JUnit. It has the same paradigms of test suites with test files. It have test cases in them, and you assert things, and if they're true, then the test succeeds, and if they're false, then the test fails. So it's unit-level testability. You can't do easily full application testing, but really unit testing is supposed to be on a smaller, granular level. So it's for testing logic inside of a class, really. It can be integrated into automated builds, especially by doing build dependencies, which I'll show you in a little bit. We have it rigged so that we do not generate a build unless the unit tests succeed. You can also use it to generate code coverage statistics, and if you use a tool like CoverStore, you can visualize them very easily. And as I said, you can set it up as a precondition to a main target build, so if the unit tests fail, it won't try to do the main build. It has some limitations, however. It's really difficult to debug. Syntax errors get flagged normally, but if you have a runtime error, like trying to send a selector to a class that doesn't implement it, then you get really obscure errors, and I'll show you an example of that when we get into here. You don't get access to all the runtime stuff, the UI stuff. You don't get access to the localization of strings because that requires bundles. The good news is there is a way you can do it. I've never tried to do it, but you can run it in the running application rather than running it standalone. But then you're getting kind of out of the unit test model because you have to run the application to do it. And if you don't code carefully, then you end up in a situation where one of the classes that depends on one of the classes that depends on one of the classes, when you pull the string to get that class, you pull so much with it that you end up with something that is dependent on a runtime feature that you don't have available, and then all of a sudden you can't test anymore. So it really pays off to segregate all of your logic, or all the stuff you want to unit test, into classes that are pretty much in isolation from all of your UI. Now that's good MVC paradigm to use anyway. You really, and practice, you don't want to be putting logic in your main code. You want to move it into classes that can be tested in isolation. So with that, I'm going to bring up Xcode here, if I can find it, and show you. Here is my application I've developed for this. It's kind of built off one of the standard Xcode application models you get. So I'm going to start by building it so you just see what it looks like. And here it is. It is. Okay, hang on a second.
Okay.
Let me try sharing again. Oh, hang on. I probably had the wrong window shared. Okay, you seeing, which screen are you seeing now?
I'm seeing a screen that says your computer screen is being broadcast to all participants.
Joy. Okay, hang on a second. I'm going to stop sharing for a second and then try doing it again. And hopefully it will not crash. There we go. Okay. Okay, are you seeing this window now with the application in it?
Yeah, good job. Thanks.
Okay, great. Okay, so here is the application. This is going to be my killer app that displaces Angry Birds as the #1 seller on iTunes. What it does is it calculates the hypotenuse of a triangle, and then in this mode here, it will calculate the volume of various geometric figures. So, wow. You can figure out that the volume of a cube of length 5 is 125. So it's nice because it's got some UI elements that we can test later on, like clicking between these tabs. It's also nice because all of the math in here is fairly simple, so that the unit tests will be fairly easy to understand. So to begin with, if you want a unit test, you need to set up a separate target inside of the application. You can do that by just doing File. Actually, it's easier to do from here. You can say Add Target, and it's going to ask you what kind of a target you want, and one of them is Unit Test Bundle, and that's the one we want to use. And then you can call it anything you want to call it, so we'll just call it Demo Unit Tests. Okay, so now if we go look down here under targets, we now have 2 different targets. Once you've got this target in place, whenever you create new files, if you recall, whenever you create a new file, it asks you what targets you want it associated with, even though usually you've only got one when you begin. Once you've created one, if there's any classes you want to be included in that target, you need to now go and set those to be in the target. So in this case, we have one interesting class to test, which is this helpers class, which has some one function to compute the hypotenuse. It's got a couple of helper functions to take input numbers and figure out if they're valid, and then turn them into floats. So what you would do is you would go here and say get info, and up here you have your targets tab on the file info, and you just add it to it like that by clicking on the target. So now let's go up here, and we're going to actually create a unit test. So we'll create a new folder, or a group actually, sorry, they don't have folders in XCode, and we'll call it unit tests. And we'll go in here and we will add a new file. And one of the options you get if you use the iOS Cocoa touch classes is Objective-C test case class. So let's call this helper tests. And what we want to make sure here is notice that it's trying to add it to our base target, which we don't want. This doesn't belong in the actual app. It belongs in the unit test. So make sure that that's the one that gets clicked. And it's going to automatically give me a framework for unit testing. Now, remember earlier I said that you can unit test in 2 different ways. You can do it in the running application, or you can do it kind of standalone during compile time. This flag here determines which one it is, just because of the way they've got this conditionalization later. So we'll just set this here to 0. And we're going to write, to begin with, a test for our hypotenuse. And because I can never spell hypotenuse right, I'm going to paste this in out of my cheat sheet. There we go. So now we've created a hypotenuse test in our .h file. Now when we go into the .m file, when I'm in the .h, I don't usually bother to remove this conditionalization here. But when you get into the .m, if you're not doing runtime testing, I just take out all of the code that's in there as boilerplate for runtime testing, and you have to remember to take that end-if out. Also, we'll change this to test hypotenuse. Now, one thing we have to do up here is if we're going to test the hypotenuse or the helper class, we have to import it, the same as you would with any Objective-C code. Now I'm just going to, because watching someone type is like watching paint dry, I'm going to paste in some code I wrote earlier for the test, but I will explain it. There we go. So let me make this into its own window so you can read it better. So what the hypotenuse test is going to do is it's going to call the hypotenuse selector on the helpers class, which is a static, with an argument of 3 and then a second side of 4. This takes basically 2 sides and it gives you back the hypotenuse. And that's going to come back as a float, and then what I'm going to do is I'm going to do this thing st asserts equal, which basically says take the first and the second item, and I just realized these are backward, and if it's true, just go on. If it doesn't succeed, then you basically display this error message, and this is essentially the same as you would get if you used a string with format. So all the things after the string itself, so everything after this, all this stuff out here up until the last one, are fed into this as format, with these as the format parameters. So what would happen here is, if it wasn't equal, it would say did not compute hypotenuse correctly, expecting 5 got whatever the number is. Now the thing I did wrong here, and I just noticed, is the format of these things is always that the first value is the expected value, and the second value is what you actually got back. So I just need to swap those, and that's because of the way that the default message prints if you don't do anything else. So now that this is in place here, I can go and make sure that my target is the unit test, and I can build it just using good old better B. And you'll notice it's hard to read, but it said build failed, 2 errors. And if I go down here and click on this to see it, here's where it gets a little boring, because you have to kind of walk down through this whole structure to find out what the error is. But if I go down through all of this, yeah, I just noticed my laptop battery is getting chewed up. Thank you. We're doing that so we don't get hum. If it gets too low, I'm going to have to put my battery back in. So if we go look here, it says did not compute hypotenuse correctly, expecting 5 got 4 point whatever. And nicely, if you click on this, it will display in the bottom window exactly where that error occurred in your unit testing. So given this, we can now say, okay, so in good old test-driven development style, we created a test and it didn't get the results we want, so let's go look at our hypotenuse code. And we're saying that the 2 sides are equal to the square root of side 1 times side 1, was side 1 squared, plus side 1 plus side 2. That's not right. We want to have it be side 2 and side 2. So I make that change. I do a build again, and now you notice it says down here succeeded. No issues. So this is now passing here. And we can, if we're really paranoid, make sure that it is in fact still running that by changing that to 4, and now it fails again, right? So we'll change it back to 5 because we want it to pass. And now we've got a good build that succeeds. Now suppose we want, I'm going to show you some other examples of tests in a second, but suppose we want our main build to be predicated off of this build, so it only, the main build only runs if the unit tests succeed. That's easy to do. Go back over to here to your main target, do a get info, and one of the things you can add here is direct dependencies. So if you make a direct dependency on the unit test target, whoops, sorry, it gets added there. Now I can change this back to being my main build, build it, and it's running that test. And again, I can prove it's running that test by going in here and changing this back to 4. And now when I run it, you can actually see down there it was running the target. Now it's getting the error again, so it never went and built the main product. So I'm going to show you a couple of other kinds of assertions you can do, and then I'll show you kind of what the whole set is. So again, I'm just going to paste these all in here. There's other helpers in that file. So for example, I'm testing here that if null is a valid number, if no string is a valid number, if 1, 2, 3, 4, 5, 1, 8 at the end is a valid number. And you notice here these are saying assert true and assert false. This returns a Boolean, so if this were to return true, I'm asserting that it should be false, so it would flag the error. You can also put in tests that are equal. So for instance, I have another helper that actually turns into a float, which is not used up here, but could be. And so I could do a test equals to see if the turning the number into a float worked right. So what are my options for assertions? You've got a few number here. You can do equal objects, which is what you would need to do to compare strings, because assert equals does more of a point or an object level or non-object level equals, so two strings are not necessarily equal to each other, but they're equal objects. Equal of accuracy is kind of fun, because especially when you're dealing with floats, you might not want them to have them be exactly equal. Some of these I've never used, like assert throws, but I would assume that means that that it's asserting that it's going to throw an exception. And then you've got assert true and assert. So there's a variety of different assertions you can make here, similar to what you get with JUnit, that can help you to exercise your code in various ways. Once you've got your unit testing in place, the next thing you would want to do is be able to do code coverage, because again, one of the metrics that's used for how good your unit testing is what's your line coverage, what's your method coverage, things like that. Now, to do this gets a little trickier. We need to create a new configuration. So go back up to our main project, go to our configurations, and we're going to make a new configuration that we clone out of our debug configuration, and we'll call it coverage. Doesn't matter what it's named, I just like to use coverage. Okay, go into your coverage build here. So make sure you're only doing it for coverage. Go down, and there's a couple flags you need to set. It's easier just to search for them. One of them is called generate test coverage. Generate test coverage files here. Click that on. The other one you need to set is called instrument program flow, which is right here. The last thing you need to do is you need to add a library for coverage called gcov. So there's a thing called other linker flags here, and you need to add -l gcov, gcoverage. Once you've done that, the next time you do a build in that target, it's automatically going to do the right thing in terms of generating coverage files. Let's just make sure that our configuration coverage here, do a build, oh, sorry. That's what happens when you remove some of your code in the demo. Okay, and I believe I know what's going on here. Notice that even though I added -lgcov, it's not finding the link here. For some reason, you have to go down into the target itself, do a get info. Again, go look for other linker flags. Not quite sure why this happens. You notice that it doesn't have -lgcov here. And I think that's because the unit test has its own library list. So you have to add it there. Now I should be able to do a build, and there we go, it succeeded. And what it's done is it's created a whole bunch of files that are called, I think, GCDA and GCNO in the same directory as the produced binary objects that it creates. You can look at them yourself, but they're kind of unreadable. There's a great tool called Cover Story, which I'll bring up here. Again, it's free. So what you do is you just open, and then what you have to do is you have to navigate to the directory, and what is it's inside the build directories, and then it is going to be coverage iPhone simulator, and I believe right here is good enough. Let's see. Nope, got to go one more deep. Sorry, I'm in the wrong hierarchy here. Yeah, it's handicap build, and then coverage iPhone simulator. And then from here, I believe you can go to the demo unit tests and do an open. There you go. So here's our coverage file, and it's showing me that, no surprise because these are the unit tests, each one of these got called in 100% of the time. You can see the number next to here is how many times it was called during the unit testing. If we go look at our helpers file for coverage, it's only covered 62%, and the reason is we didn't write any unit tests that test get float val. If we want to fix that, we can write a quick unit test by going back to XCode. I'll just go here. So you do have to watch me type this. So test float val, and we're just going to say st assert true, that actually we'll do a st assert equals that helpers get float val, and it takes a string, so we'll just say 5 is equal to, and again, we got to remember that the first value is the value you're expecting, so that's 5.0. And I'm not going to even put a message in because we're just showing this for coverage, so you can just do that. If you do that, by the way, actually if you do nil-nil, it has kind of a default message it uses, just saying that the two things aren't equal. Now I'm going to show you a little gotcha here now. So I'm going to build that. Got an error. I wonder what it is. Maybe it's not. Oh, you know what it is? It has to do with casting floats, I think. Yeah, type mismatch. And the reason that happened is it's comparing a float with a float, so you have to do the cast. There we go. Now it succeeds. Now the problem you're going to run into is, even though it should have generated new stuff, what I've found here is, you notice I did a refresh and it's still here with 0 coverage on that. The reason is you actually have to do a build clean, which you can't do unless you stop your simulator. There you go. So I find if you clean all targets before you re-look at your coverage, it works better. Especially in the cases where you're looking at a file you've already looked at. So now, hopefully, when I reload this, now I have 100% coverage on both of them. This is called 6 times because I have 6 different unit tests for it. This is only called once, as is the hypotenuse code. So I want to talk about one gotcha here, which is that, as I mentioned, it's really hard to debug this stuff. So I'm going to put in something here that just isn't going to work. So if I say helpers I don't exist, right, there is no method I don't exist, the error message you're going to get here, actually that one was relatively good. Let me make that a little easier. If I say, for example, helper, actually, here's a good one. If I say ns-string foo equals nil, and then I say, actually, again, that's going to probably work because most of the string things will take an argument. I probably should have actually thought of a good example of this. But what essentially is going to happen is the error message you get here and it's not going to happen, and I apologize, you'll get things like, you won't get an actual useful backtrace. What you're going to get instead is system error 154, and it won't even give you a line number. So runtime errors are very hard to pick up in your unit test code. So you know, you can either use logging, or you can just be very careful in the code when you write it, because I have literally spent hours trying to figure out why a unit test won't work. So that was unit testing. I'm going to move on now quickly, because we are in fact getting short on time here, to UIAutomation framework. It allows you to test a lot of the UI of the application, although not all of it, because there's certain things that you can't trigger via the tools. It was introduced in iOS 4. It's part of the Instruments tool, which some people may have used to do things like memory leak detection. And it can, in fact, be used in concert with other instruments such as that, so you can run through the whole application and see where memory leaks are occurring. The limitations are is it's somewhat buggy. I've got several bugs open with Apple for it, and I may have time to show you a couple of them today. You can't run it in an automated build because it requires you to start up instruments and load in something and run something, and then when it's done it doesn't stop automatically, so you have to stop it. So its main feature is that if you're doing regression testing of UI, you don't have to have your UI people, QA people, hand typing everything. They can just watch the run happen very quickly and figure out if it works or not. It also doesn't provide access to all the properties, such as color, so you can't test if you've changed a color based on an error, for example. And certain controls like labels, labels have a quirk. UI label, if you change the text of the label, that becomes the name you access it by. And I may have time to show you that. It just gets really weird when you're testing labels. In fact, in most of my code, I don't use UI label at all. I use UI text field with the interaction flag turned off, because that you can give a name to and then test the value to make sure it got the right translation, for example, if you're testing localization. So, assuming that you're still seeing my screen here, I'm going to bring up instruments, which I've already got open here. You can get to that, by the way, if you just go to Spotlight and type instruments, it should find it. Create a new instrument. You want to pick iOS simulator, and then one of the options you get is automation. So it's going to create you an automation band here, and one of the things you do is you select basically the JavaScript that's going to be run against, because UIAutomation is done with JavaScript. So what we're going to do here is we're going to, this is actually one of our test ones. I need to pick the one that I wrote for this. So I'm going to go and I'm going to choose one I've already written, and I'll walk through it with you. So first I'll run it just to show you what it looks like when it runs. Now one of the things you have to do is the first time you run it, see it says up here choose target? You actually have to tell it where the app's binary is. So you just have to kind of walk through here again. Let me take a second. You also can't double click anything. And then once you get in here, where's Webcast? There it is. You walk down again to the build, and inside of the build you're going to find, you want to use the debug one probably, and you walk down far enough. Sorry, you got the demo unit tests here. I want the ever target. I want handy calc. There it is. And then you just choose the app. Actually, sorry. You go into handy calc. I keep doing this. And then you go into debug, and then you go into here, and one of these is the application. Or I could just be wrong altogether. Hang on a second. I know where it's living. There it is. That's the app right there. So now that I've selected it, what it's going to do is it's going to start up the simulator. It's going to start up the app, which takes a second. And in fact, if you go look here in the background, you can see this whole timeline running. So here's the app open, and now I've got a whole bunch of tests that it's going to exercise. Now it waits a second after the app is open also to make sure that everything has had a chance to initialize. Okay, so I've actually run the, you can see the tests are running in the background here, and looks like all of them failed. Now that may not actually mean it failed, because one of the things I found here is that it doesn't always work first time you do it, so I'm going to try it again, because I know this test actually works. Or maybe not. Alright, I'm going to go in here and I'm going to show you the actual code for it, and then we'll figure out why it's not working. Does it help if I tell you it worked 5 minutes ago? You can click on the edit button, and here's the JavaScript for it. Basically, you navigate down through the app by doing things like saying UIA target, which is the top level thing, local target, frontmost app, which is the window that's open, or no, the application that's open now. You can get a handle on the main window, and you're walking it like a DOM. So the way it works is you say UIA logger log starts a test, and then you either log pass or log fail. And then that will cause it to print one of the fail or pass messages here. Excuse me a second here. These messages here, they're all failing for some reason right now. They were passing earlier. And you can do things like check to see. Here's an example. So you've got your view, and then there's a bunch of accessors off the view. For example, static text gets you back an array, JavaScript array of all the labels on the page. They're not unfortunately called what you'd think they're called. They're called static text rather than labels, or text fields rather than, well, text fields is text fields. And from that you can then walk down the third or the second, or you can reference them by their name. The way you set a name is if we go back into XCode and then we bring up Interface Builder. So let's get up our view here. There we go. So if we go look at the view and we go click on an element, let me bring up the view here so you can see it. So if we, for example, click on that, then when you go to its little I tab at the end here, there's an accessibility flag which you have to enable, and then there's a label. And if you set the label to something, then it will succeed or fail. And I just realized why it's failing. I haven't set any of these labels yet because I wanted to show you how to do that. So if we go look at my test file here, we can see what I think I want to call them. And I'm using, here we go. Sorry, wrong one. My apologies. Here we go. Right. I'm using the name side label 1 and side label 2. So when I go in here and add that property through Interface Builder, so I've got that selected. I could just drop in side label 1. Here, I'll put in side label 2, the side 2 label. And then this is side 1 val and side 2 val, and this is how you can access these through your UIAutomation tool. Save it. Now I have to rebuild the app. I don't have to repoint instruments because it's just pointing at that binary. Now if I run this, it should at least a few of them are going to pass because it's going to find the values now. What it's checking to make sure is I'm on the right screen and I have the right fields available. Okay, still not working. But that essentially is how you set the values that you access. If we go again back to here, you can see that I'm looking for the side 1 label object and hoping to get it back. Now, as I mentioned, the weird thing about static text fields is that the value is actually the text in it, not the label name you give it, unless you set a label name, and then you cannot access the value of the field anymore. There's a name field and a value field, and the name field isn't accessible once, or sorry, the value field isn't accessible once you hit the name. And in fact, I can go walk in through here and say, didn't find side 1 label. And sorry, there's a way you could dump the whole, the entire structure, and it's down here where you say log element tree. So to finish off, because we're running out of time here, I'm just going to drop this in at the top so I can show you how you actually find the structure. So I'm going to run this again. The first thing it's going to do is it's going to dump that structure out just to the output log here. You know what really helps is if you put this after you've set app. Here we go. Has to go after that. Now, as I said, you notice it doesn't stop. You have to manually stop it, which is a pain in the butt. And it waits 5 seconds before it starts. There we go. So now you can go through here, and you can actually, once you've made that call, you can go click on elements and see what their values are. So I can see, like, here's a static text field, and its name is side 1, right? So even though I'm testing here for what I set the label to, because it's got a text value of side 1, that's actually what it's looking for. So if I go up here and I change this from side 1 label to just side 1, now at least that one thing is going to pass. There's also a problem I'll mention quickly, that if you set a view to have a name, then everything under the view disappears, and I have a ticket open with Apple for that. Okay, so now we have a pass here, because I set that, because it found the side 1 label now, because I used the text value of the label, not the value I had given it in instruments. I'm going to show you really quickly where you can find documentation on this, although it's not great. If you go into developer.apple.com in the iPhone section, there is, and search for UIAutomation, you'll find this reference collection, which is essentially just documentation. It lists all of the classes that are available, and then if you go through into it, it will tell you things like their accessors and the methods you can use, but really it's extremely minimal documentation. You have to use a lot of trial and error in here. I think at this point, given we've got about 5 minutes left, I'm going to see if there's any questions here. I apologize, especially in the UI automation, it got a little confusing, but I hope you at least saw what the paradigm is there. So, Catherine, do you want to hand me some questions?
Sure, James, and thanks. That was great. You don't need to apologize. I've seen there's some in the live demo that makes things not work. But I'm getting really nervous about that. Maybe you want to plug in. And then there are a few questions, so let me start from the top, which means that they're at the beginning of your talk. And when you started talking, Andrew asked, he said, I know that OCUnit is included with XCode, but don't most people use Google Toolbox for Mac?
A lot of people do use it, and they also use it for doing UI testing. Honestly, the reason we didn't go that way is because when you start using third-party tools, this is kind of the same conversation we had about using one of the third-party UI generation tools and going and doing one application that was used throughout all of the different platforms. Once you start using third-party tools, you can get into the situation where you get a point update to XCode and all of a sudden your tools stop working. So we really made an effort to stay with Apple's tools in the hope, which wasn't always true because they, for example, broke UIAutomation in one point build, that the tools would continue to work as we went through the evolution of the iOS versions.
Okay, and then another question from Andrew, and I'm not sure at what point he asked this. I think it's when you were showing the assertions, but he said it, so is it considered good practice to have only one ST assert call per method?
That's getting more, and I apologize, I had to plug my power in before I lost it. That's kind of the philosophical issues of unit testing. What I try to do is when I write unit tests, you want to do asserts for things that are required before you do your main test. So that if, for example, something you're expecting to return a value that you're then going to test on for some reason returns nil, you don't assert, you don't fail the main assert because one of your parameters is wrong. I do tend to like to have one main kind of thing I'm testing in each unit test, because if the name is useful, then I can just go through and say, oh, okay, the test it failed is when the string is null, and I try to get its length. Rather than, if you've got a laundry list of them, then it can become kind of hard to figure out which aspect of that unit test failed.
Okay. And then Michael asked shortly after that, does universal access have to be turned on in the simulator?
I haven't had to do that. I think they fixed that at some point. I remember I used to have to do that, but I think that hasn't had to be done for a while. I think somewhere in one of the later SDKs they may have fixed it. If it does cause a problem, I remember you used to have to do that. You had to actually go in and set a flag in the simulator, but I haven't done that in 4 or 5 simulator upgrades, so I don't think that's necessary anymore.
Okay, great. And then Shriran, excuse me if I'm not saying your name correctly, is asking, what about painted controls that are just painted by the application? Do they need to support some provider interfaces so they can support UI automation? And after he asked that, I think someone asked, do you mean custom UI view subclasses? And Shriran answered perhaps that he's using Windows terminology.
There are, if you're creating elements programmatically as opposed to interface builder, you need to set those parameters in the object when you create it. I honestly haven't used automation a lot with it, but it's going to be whatever the accessibility label property is on the base element, so that it becomes accessible. Or you can always do it positionally, because when you get that array of static text specs, for example, if you know the third one on the page is the one you're interested in, you can just do bracket 3 bracket rather than try to access them by name. There is a lot of stuff you can't test with UI automation. If games are totally untestable in UI automation if they're doing like OpenGL, because there's absolutely no support. This is really meant for testing text boxes and labels and pull downs and button pushes and choosers and things like that, which you can automate all of those. Now there is, I will take that back, there is the ability to just randomly do a touch on a location on the page, but you can't tell if you're displaying the right image for that. You can't even tell if you've set the right color for something, because again, that property isn't available.
Okay, and Shriran said, but position can change in a Scrum.
Yeah, position can change in a if you're creating dynamic elements, but it's actually, I think, fairly smart about, I think it uses Y ordering when it gives them to you through the UI automation tool. So as long as you're not changing the order that they're on the page, you should be able to say the third element, for example. And you can also use JavaScript to iterate over elements and look for the right one.
Okay, we're almost out of time, but Andrew had a good question, I think. I'd like to know what the answer is. He asked, can UI automation be used to test UI gesture recognizer subclass?
I'm not sure about, you can do gestures. You can do pinch, you can do swipe, you can do orientation changes. I think you can do shake. I'm not, again, if you go look through here, you've got gestures and actions here. So these are the gestures that you can easily use. You can do pinches, you can do flicks. there are other, it's not a full list here, so if you're adding gestures, you can simulate the gestures. If you add a gesture that just totally isn't a normal Apple gesture, I don't know if you can test that or not.
Okay, and then one more little question. Actually, I don't think it's such a little question. Miguel is asking, how is your team doing continuous builds and tests for iPhone apps?
We're using a tool called Hudson, which basically just fires off Ant scripts. Then we have Ant scripts, and then the Ant scripts are calling the command line Xcode stuff to, which is semi-documented, to do builds. You could, in fact, you could do all the normal debug builds, anything that isn't signed from the command line and it's documented. There is documentation on how to do things like do a signed ad hoc build or do a signed build for the iPhone store, but it's depending on undocumented Xcode features and undocumented commands that people found out by doing S-traces on Xcode while it was running. So we're using those at our own risk. Again, that's mainly because they want to have, for example, one of the nice things we're able to do is we do an ad hoc build. We have about 30 or 40 devices we're using for testing now. We build an IPA that's signed with the ad hoc build, so people could just go to that directory, grab the IPA, drag it in, and I don't have to give them a hand-built IPA or hook their device up to my machine and do a compile.
Okay, great. Well, I think we're out of information. We're out of information. I was going to say great information, James. Thank you. And that we're out of time, and I see that people are starting to drop off too. So we should wrap it up. But I just want to thank you for doing this, and thank everyone else. We had a really good group here today with lots of expert advice from a lot of the people here, which I think is wonderful. I really like it when that happens. So thank you so very much, James.
My pleasure, and again, I hope that it was useful to people.
I'm sure it will be. And for everyone who's asking, we will get the recording out in probably a couple days. It takes a couple days to get that out. We'll send a link to everyone who registered, and if you didn't register, just joined without that, then you can check back on our Webcast page, which is O'Reilly.com/webcast, and it'll be archived there. So, once again, thank you, everyone, and I will hope you join us next time. All right, bye-bye.